So, dahan-dahan lang nating i-discuss, no pressure, no, para ma-solve nyo kasi may feedback na hindi nyo pa no, hindi pa na take up yung ibang mga formula sa pumps, no? So i-review natin yung pumps para masagutan nyo. So sa Thursday, kahit hindi na siguro tayong mag-class, no? Masagutan nyo lang yan, tsaka i-review nyo lang yan, no? Kasi hindi na ako asynchronous dahil hinahabol natin yung no, pero we'll give time para Webes, sa Martes pala, no? Next week, Martes, hindi na tayo magkaklase. Wala naman pala tayo talagang class ng Webes, no? Kasi sa next week, next Thursday, na natin, no? Exam na, no? So, ang ina-expect ko, I'm expecting na masasagutan nyo yung tungkol sa mga pumps kasi i-discuss natin this afternoon. Okay? So, medyo rush lang, medyo rush lang, pasensya na. I just scanned yung mga formula sa pumps galing sa reviewer and then yung mga old notes ko, no? Para ma-take up lang natin yung mga pumps, no? At nandito naman lahat yon, no? So, ito yung mga formula sa pumps, no? Medyo maliit. Ngayon po, if I'm going to to zoom in, meaning if I'm going to stretch, if I'm going to scale up, medyo madi-distort. So, tingnan na lang natin yung mga basic formula na na-take up naman natin to, no, in the course of the the subject. We were able to take up yung mga iba dito, no. So, ano ba yung mga mahalagang formula? What are the critical and important formulas in fluid mechanics or hydraulics, or in this particular um, topic, pumps, no? If we are discussing about pumps, so we could not we could not we could never neglect yung flow, no? Volume flow rate. So ano yung volume flow rate? Q. Baguhin ko yung, let me get another, no? So what are the important formulas in um, in pump, no? So pump tayo. Dito ko na lang sa gilid, sa blank para kita. So we have this volume flow rate as exemplified or expressed in this notation Q, and this is none other than nothing but the product of two parameters, area and velocity. What is that? Area is in units, unit check, meter square, and the velocity is meter per second, no? So, lagyan na natin ng dot. If you multiply that, it will become meter cube per second. Now, that is in SI or metric. Sa imperial or English, no? Galing sa England, imperial, mga hari, no? Imperyo. Kaya imperial, no? Empire, British Empire. Ano to? Cubic foot per second or gallon per minute. Yan. So we should know those units, no? English and metric or SI. So, yun ang mga kailangan nating malaman. No, so ano to? Meron tayong tinatawag sa fluid mechanics, meron tayong tinatawag na principle na sinusunod. Ano ba yung principle na yon? Let me erase, no, so that we can we are being guided to revisit the principle of Bernoulli. Yan. So, Bernoulli's theorem or Bernoulli's principle. Ano ba yung pinagsasabi? Ano ba to si Bernoulli? Ang pangalan ni Bernoulli is si Daniel Bernoulli. No? Daniel Bernoulli. And then, what he is saying is that in analyzing the flow, no, of flow of fluid, no, at a certain point, no, halimbawa from point A to point B, from suction, no, isasak muna tapos i-discharge, for example, at a flat from the river from the river to the mountain, from the river to the house, from the river to the building, meron dalawang point, no? Ang sabi niya, meron dalawang point na kino-consider. Halimbawa, ito yung pump, no? So, ito yung suction, tapos dun yung discharge, no? Ang sabi ni Bernoulli class, meron siyang tinatawag na datum, no? Reference datum, yung center line. So, all the energy dito below the center line is what? Algebraically negative. Ito ay above center line, so positive, no? So, ito yung suction, no? Yung suction dito sisip, no? Or source. Dito naman yung discharge. Ano ang meron sa suction? What do we have? What are the parameters in the suction? So, binanggit ni Bernoulli yun, no? So, Daniel Bernoulli enumerated all the energies involved. No, ano yung mga energies involved? So, ang mga energy na involved, sabi niya, tinawag niya yun ng mga head, no? Head or energy head, no? Energy head. So, meron siyang pressure head, ano pa? Velocity head, no? So, pressure, tapos velocity head, tapos yung sa, ano, no? Yung due to position or elevation, no? Meron tayong elevation. Tapos, meron ding kasama, no? It is included yung may mga friction, no? Friction head, loss, no? So, friction head due to surface, due to length, no? Habang mahaba, maraming pressure drop. Di ba? Pag mahaba yung ano, yung tubo, no? Pagdating sa dulo, baka patak na lang o napakahina na, no? So, may mga head loss na tinatawag, no? So, ngayon, to summarize what Daniel Bernoulli is trying to express, meron tayong tinatawag na TDH, no? So, total dynamic head. Yung total dynamic head is the summation of all the heads, no? So, yung pressure, velocity, friction, no? Saka yung elevation, meron niyang total dynamic head. Ano yung total dynamic head? Yung total dynamic head is yung head, no? Total dynamic head, TDH, no? Head, total dynamic head, TDH, is the algebraic sum of the two. Ibig sabihin, yung between 2 points, no? Point 1 and point 2, no? Discharge minus suction, no? Halimbawa, ito yung Z, no? Elevation ng Z ng 2 minus 1. Tapos, i-add mo, ano pa? Yung pressure, no? Ng discharge minus pressure ng suction, pressure head. Ano pa? Plus mo yung, meron tayong elevation, may pressure, velocity, no? V squared over 2G. Velocity ng discharge minus velocity ng suction. Tapos, plus HF, friction head. HF, friction head ng discharge minus friction head ng suction. Okay? So yun yung totality na pinag-uusapan natin when we are talking about the total dynamic head, no? So if I may reiterate, so this yun, no? Ito yun. The total head is this, no? So, i-rearrange lang natin if you want to rearrange. So, yung sinasabi dyan ay yung pressure, no? Pressure at discharge minus pressure at suction plus velocity, no? At discharge minus velocity at suction plus elevation head at discharge minus elevation at suction. Then, yung friction head, no? HF, friction head at discharge minus friction head at suction. So if you get that, you will have this total dynamic head. Ngayon, we can expand ito yung pressure, no? So how do we expand the pressure? Ito yon. Yung pressure head, nandito yan, makukuha. The velocity head, makukuha kasi it has to do with the gravity, no? V squared over 2G, I guess, no? V squared, no? Over 2G. Then, elevation head, ito lang naman ay yung taas, no? Yung head na in terms of vertical elevation. Tapos, ito yung friction head, normally it is given, no? So, meron ding tayong, we have also another parameter that we are going to consider, that is hydraulic or water power, no? So, power, no, yung power, subscript water. Water power is, what's this? Ano ba to? Anong unit to? Density, no? Times Q times H, no? So we have to know the volume, the density, because iba-iba namang fluid eh. Baka langis yan ang pinapump, or gasolina, o alcohol, di ba? Or brine. Ano ba yung brine? Tubig tsaka salt, no? Pero normally the universal solvent is water because it's very abundant, no? You know, on Earth, no? 3/4 ng Earth ay water. 1/4 ay land or Earth, no? That's why it is called universal solvent, no? So eto, no? We have to multiply with the discharge and with the head, no? So normally ang tubig ay 1,000 kilogram per meter cube, no? So it is called yung specific weight niya, no? So weight, no, per meter cube. So tingnan natin to, ano ba to? Meter cube, no? Per second, no? Ito naman ay head, is meter lang, no? Kilogram meter per second. Tama ba tayo? Meter cube per second, no? So kilogram meter is like a force, no? Or energy per unit time is power, no? So kilogram, no? It's a force times distance, it's energy. Energy over time is power, right? So yun yun, no? Tapos mako-convert lang natin. So how about efficiency? Lagi naman yung efficiency is what? So pump efficiency. Eta yata yun, no? Di ba? Eta. So pump efficiency is always the output over input. Lahat naman ng efficiency is output over input. In our case, it is the Q, no? Q total ba to? Tapos yung power. Ibig sabihin yung Q na discharge over yung power na kailangan, no? Power na input, no? And so there are motor efficiency because motor ang magpapatakbo ng pump. So yung output ng motor, yun naman ang input ng pump. 'Di ba? Ganun lang naman 'yon. And what are the others? The others are the characteristic, no? Reciprocating characteristic. Yung sinasabing characteristic diyan, no? May mga characteristic na binabanggit diyan. Mababasa niyo naman, no? And actual discharge, slip, no? Slip, yung meron tawag volumetric efficiency, meron din, no? Yung volumetric efficiency, volumetric flow rate. And then lastly, I think ang binibigay diyan ay yung affinity law. I don't know, no? So kasi because this fluid, whether air or fluid or water, this affinity law, meaning yung mga parameters sa pump ay may kinalaman sa bilis, no? So, pag ni-ratio mo yan, may kinalaman sa bilis yung mga parameters. Ano ba yung mga parameters? I think yung QWH, let me, meron akong sa notes ko, no? QWH ba yun? Ayan. QHP na. So ito, yung QHP, no, QHP, ano to? Yan. Yan, tinan nyo, nag-i-straight, no, parang magic. Yan, no? Pag sinulat mo, mag-i-straight kasi part siya ng, yung digital pad ko, meron siyang whiteboard na tinatawag, no? Whiteboard. So, kaya niyang anuhin yan. Kaya niyang straighten yung dyan. Yan. Whiteboard. saka full screen snip, no? Whiteboard. So, ibig sabihin, ito ay QHP. Tingnan nyo, yung Q, 1. Yung H, second power, yung P, third. No? So, tandaan nyo lang, babalik tayo rito para malinaw bago tayo mag-solve ng isa o dalawa, then kayo na sa iba. No? So, eto, QHP. QHP. Ito rin yun, no? QHP. Yan, no? So, ilagay ko na lang dito, we will put here para hindi tayo nalilito, para matapos na rin tong ating lecture. Yan, dito. So, I'll present full para maano, no? So, QHP, paano yun, no? So, ito ay QHP. Ibig sabihin, yung yung pag nag-design ka ng pump, halimbawa, i-consider mo dalawang pump, no? Pwede mo siyang i-ratio and proportion kasi ito ay nakabase dito, no? So, yung QHP natin, N1, N2. So, raised to 1, no? So, proportional daw yung volume flow rate sa speed. Tama nga naman, di ba? As the motor, the speed of the motor is driving the pump, no? As it drives the pump very fast, lumalaki yung discharge, di ba? Proportional, 1:1. What about head? Yung head na 1 ay nasa second power. Yan. Ganyan. Yung power naman is behaving in terms of the third power, no? Cube. So, 1, tinan nyo, 1, 2, 3. Third power yung power, no? So, let me go back para makasigurado tayo, no? Basta ang tatandaan nyo lang ay, yung variable. Ito, no? Q, no? So, ito, QHP. Pag yung Q, no? Q1 over Q2, N2, ito na naman yun, no? So, N1, N2 to the 1. Pag H naman, to the second power. Pag power naman, to the cube. No, proportional lang yan. Proportional. So, mag-solve tayo mamaya dyan, no? So, let me start with the problem solving so that we can see the application and then later yung mga ibang problems. Okay? So, let me present this to you, class, para ma-review tayo, no? So, the problem says, no, it is my old notes, hindi ko na nga na-type, in-scan ko lang para mabilis, no? At least mapakinabangan natin lahat, no? We can benefit from the old notes of this, no? Later, pag may time ako, o kayo, no, i-PowerPoint na lang natin para mas malinaw. So, let us solve this all together, no? So, water from a river. Saan yun? Where's that? Here, no? So, dito yung river, ito yung river surface niya, no, ng water, is to be pumped on a hill. So, from river, ito yung river, ilog, iaakyat niya sa hill, no? Kaya nga mas, yan, no? Hill. Matataas, medyo mataas yan, hill, no? 122 meter above. So, from the surface of the water in the river, kukunin mo yung vertical elevation, no? Ito halimbawa, vertical elevation. Ito yung discharge, no? So, dito, mula dito, from here to here, you should able to pump the water with this elevation, 122 meters. The flow is 3,600 meter cube per hour, no? So, ano yung flow? Volume flow rate, no? Q or Q dot, depende sa inyo. 3,600 meter cube per hour. Ang laki nito, di ba? Kuminsan yung mga problem, it's not, parang realistic. 3,600 meter cube. Alam nyo ba yung meter cube, no? Dumi pa ka, di pa, no? Tatlong yon, watt meter cube. Ito 3,600 meter cube per hour. So, ibig sabihin, napaka-laki ng discharge niya. Now, we continue. And the tank will be maintained at a pressure of 138 kilopascal. So, yung tank natin, if you see this, no, we are pumping from the river to the hill, and of course, merong reservoir, meron tayong lalagyan, ang tawag doon ay tank. Sa tank na ito, i-maintain natin yung pressure, 138, no? So meaning it is a closed tank. How can I say it is a closed tank? Because it is a pressurized tank. If the tank is not closed, meaning if the tank is open, pag ang tank ay open, ibig sabihin ito ay atmospheric. And what is atmospheric pressure? 14.7 psi. So ilan to sa sa ilan yung atmospheric sa kilopascal? 'Di ba 101? 101.325 kilopascal. Yan. Okay? So ito more than atmospheric 138. You have to maintain the pressure in the tank at 138 kilopascal. Now, there are others that are being mentioned in terms of other parameters. The friction head is estimated at 4 meters. So yung friction head, HF, is 4 meters. Now, the question is, find the water horsepower developed. So, find the horsepower, water horsepower. So, power, water power. No? So, these are the given, and we are asked to find the horsepower. So, how do you find the horsepower ng motor na mag-drive sa pump? Ito yung pump po, di ba? So, nasa center line yung pump. Hindi na pinakita, pero siyempre, dinadrive din ng motor. No? Siyempre, wala naman diyang, kung may kuryente, may wire. Kung hindi naman, engine, no? Pero, mag-drive pa rin siya. So, how do we solve this? So, this problem is the kind of problems that a Bernoulli equation is applied. No? So, ano ba yung Bernoulli equation again? Bernoulli equation says that law of conservation, para tong thermodynamics law of conservation of energy. Anong ibig sabihin nun? Mass and energy, no? So mass in equals mass out. Energy in or energy entering, energy in equals energy out, no? So kung ano yung pumasok, yun din ang lalabas, no? So kung may pressure ka sa suction, discharge pala, no? D. So all these are discharge. Pressure at discharge, no? Over the specific weight, you will have an energy, no? A head. Then ito, VD, velocity, VD squared, and Z. That is elevation, no? Friction loss at discharge, HFD. So whatever you have in the discharge, you also have in suction. P over, ano ba tong letter na to? Ito lambda. Ito ay rho. Gamma ba yan? So gamma, no? So may Greek letter na P, specific weight lang naman yan, no? Then at suction, you have also velocity, V squared over 2g. Then at suction, you have the elevation head. Yan. Meron ka ring head loss due to friction, no? HF, suction. Tapos dito naman, HF, discharge. Then the totality is yung head, no? Ito plus yung head. Now, if you want to get the head, the total dynamic head, so pwede mo siyang ilipat-lipat na lang, no? So ito, ililipat mo rito, no? Yan. Lipat mo doon. Magiging negative. Diba? So, ito na yan. PD minus PS. Ito naman. Lipat ko yung VS squared over 2G. No? Ina-minus ko rito. So, ito na yon. Lilipat ko uli yung elevation head at suction. Ima-minus ko din sa positive na dito. ZD minus CS. Then, meron pang natira. Yung HF sub D, lilipat ko tong ganito. So, magiging plus, no? Kasi minus dito. So, plus ko na lang din, no? Madadagdagan yung head loss niya, magiging positive HFD. no? HF discharge dito, no? So, ayun yun. Okay? So, HFD minus HFS, no? Malilipat dito sa kabila. So, we go now to the notation. What is H? H, pump head. S is suction. D is discharge. P is pressure. V is velocity. Then this one, tung gamma, no, is density or specific weight, no, kilogram per meter cube, density. The others are using raw. Ito naman ay ginagamit dito ay ano, yung gamma. Then VD, negligible, 0. VS is also negligible. So, meron na tayong maka-cancel, no? Na ano, yung velocity part. PS, ano to? Gauge pressure, no? And VD minus CS is 122. So, kung titingnan natin, yung pressure, gauge pressure, no? Suction is the gauge pressure dito. Then, velocity head, no? Ito yan, it's 1 over 2G. Tapos, yung ano pa yung isang head natin? Pressure head, the velocity head, saka yung elevation head. Binigay naman elevation head, no? Yung total is 122. So, balik tayo sa drawing, no? Ano yung mga head na binigay? What are the heads that are given to us? Ito, Z, no? So, ito, Z. Ang Z na to ay Z0. Ito naman, Z ng discharge. So, ZD minus ZS is 122. Then, the flow rate is 3,600 meter cube per hour. Then, this one, pressure at discharge is 138 kilo Pascal, no? Doon sa baba, siyempre atmospheric lang kasi open naman, open channel to open river, no? So atmospheric lang yan diyan, no? So tingnan natin how do we solve this in this case, no? Na-define na natin yung mga configuration. Now we are ready to solve the problem. Actually, the problem is the water horsepower, no? So how do we do that? Let us start with the pressure, no? How do we calculate the pressure head? We were given the pressure head is 138 kilopascal at discharge. Now, we are going to maintain the tank pressure at 138 kilopascal. So, in this case, we have to do some kind of conversion, no? So, since it is given in kilopascal, no? So, we are going to convert in Pascal. Now, so 1 kilopascal is 1,000 Pascal. So, cancel, 1,000 Pascal. Now, yung Pascal ay equivalent ng Newton per square meter. So, what does it mean? So, Pascal, 1 Pascal is 1 Newton per square meter. So, cancel na pareho yung Pascal. What will be left is Newton per square meter. Now, there is 9.81 Newton for every kilogram. So, makancel yung Newton. So, kilogram per square meter, no? And then, sa baba is yung density or specific weight, kilogram per meter cube, no? Kilogram per meter cube. Tsaka dito sa kabila ay, ano, kilogram ano nito, kilopascal, then pascal. Ito naman ay kilogram sa cancel yung ano to, square meter, no? Cancel yung newton, then kilogram per square meter na lang, no? So, kilogram, ito naman maka-cancel na kilogram sa kilogram, cancel na lang. So, yung meter, isang meter dito, may isang meter, tsaka ito yung isa, so meter square. So, mangyari dyan, magkakaroon ng velocity head mamaya, no? So, let us check. 138, ang natira na lang, what will be left is 138 times 1,000 divided by 9.81, which is the velocity, no? Acceleration due to gravity, which is 9.81. Then, ito naman ay 1,000, no? 1,000 dito. So, ang magiging answer is head, no? 14.067 m. So, VD squared over V squared over 2G. So, negligible na yon. So, 0. That's negligible. So, 0 na lang. Then, the elevation head is given 122, no? Mula sa water line ng river papunta dun sa discharge na pinalalagyan niya sa ating water pump, no? So, if we're going to continue the calculation, so ito ang mabibigay sa atin, no? VD squared minus V squared equals 2G, meaning ZD minus CS, elevation head is 0. No, so ito, ZD minus CS is 122, which is the elevation head. Then friction head loss is 4 meters. So the pump head is 14.067 plus 122 plus 4. So ito yun, 182. That is the 122 is the elevation head. Then this is the friction head, 4. Then this is the calculated, no? Yung 14.607, kinalkila naman natin yon, na formula galing sa Bernoulli. Ngayon, ano pa ang dapat nating solvein? Di pa tayo tapos. We are going to solve for water horsepower, no? So before we can solve the water horsepower, so power, no? Water horsepower, it has a formula of Q, katulad ng solve natin kanina, specific weight times head, no? So, meaning, kukunin natin yung mga lahat ng head, tapos kukunin natin yung specific weight, tapos kukunin natin yung discharge, no? So, we have this data based on this problem na yung head ay 122 in this particular problem. Friction head is given 4, no? And then, ang H is total pump head, no? Yung H, kailangan natin yan para ma-plug in natin dito, no? So, ano po yung head? We have to sum up. We have to just add all the following heads, meaning the 14.067 na it was calculated, yung unang head na kinakalculate natin na 14.067, and then meron tayong tinatawag na na yung specific weight, no, or density ng tubig, 1,000 kilogram per meter cube, no? Tapos etong ating discharge, ito 3,600 meter cube is the discharge, it is given. The specific weight is standard 1,000 kilogram per meter cube. What we really did solve, what we calculate is the head na remaining, no? So ito yung 14.067. Pag tinotal mo, then ito yung given na 122, yung elevation head, ito naman yung friction. So, I think there's no problem. All we have to do is to multiply the three variables. So, we have to multiply 3,600 meter cube per hour times 1,000 kilogram per meter cube, which is specific weight, times the total head available, 140.1, no? Ito yun. It was all just rounded up, 140.067, 140.1. So, pag multiply mo to, yung 3,600 times 1,000 times 140, and you have to do some conversion, then you will arrive in horsepower. Okay? So, all we have to do, let us check the units, no? Because the numbers, we just plug in, we just press. We press the calculator. What I'm after is the unit, no? So, meron tayong meter cube per hour, galing sa 3,600 meter cube per hour, tapos kilogram per
meter cube. So, ito answer. So, kilogram per hour. And then, meron tayong meter, no? So, may meter tayo. Kasi head. So, what will be left is kilogram meter per hour. Okay? So, anong mangyayari sa atin sa kilogram meter per hour na yan? So, ilipat ko dito. I just have to transfer this so that it will be clear to us. So, how could we get horsepower from this kilogram meter per hour? Right? So, how did we get yung, yung hour, we can convert into seconds. Okay? And then, yung kilogram meter, pwede naman pala sa foot-pound. Okay, 150 foot-pound, no? Tapos, makakonvert na natin ng horsepower. So, we have to convert this to what? Foot-pound, no? Per hour. Pag na-convert na natin siya, i-divide natin siya ng 550 in conversion factor, foot-pound, i-multiply natin siya ng foot-pound, tapos isang horsepower. Lakas pala itong horsepower, no? So, isang horsepower, foot-pound will ba cancel? Kilogram, no? Yung kilogram, dapat i-convert natin ng pound, no? So, isang kilogram, no? 1 kilogram is 2.2 pounds. So, nga dyan, cancel mo yung kilogram. Tapos, ito na magiging, ano siya, foot-pound, no? Yung kilogram magiging pound, tapos yung meter magiging feet, no? So, foot-pound, tapos yung hour magiging second, no? So, foot-pound per second, tapos times kilogram, diba? Kilogram dito, tapos meter, magiging kilogram, uh, dati isang kilogram meter, no? Dati isang kilogram meter per hour, naging foot-pound second. I-divide mo siya ng 550 foot-pound per horsepower, no? Magiging horsepower siya. Ito, ito yun. So, if you do that, no, kasi yung hour, multiply natin ng, no, isang oras, 3,600 seconds. So, cancel yung hour, divided by 3,600. So, magiging 550 foot-pound per second, no? So, ang total, ang unit niya, magiging foot-pound per second. So, ang gagawin mo, over 1. So, ito, meron kang 550 foot-pound, no? Sa isang horsepower, foot-pound second sa isang horsepower. So, ang mangyari niyan, foot-pound and foot-pound, then second per second, then magkakaroon ka ng horsepower, no? So, ito. Water horsepower is 1,838.11. No? So, ano pa? So, mag-take up ako ng isang problem, tapos, kayo na ang sa iba, no? So, yung number 2 kaya, parang exciting too, no?
So we go now to the second problem. And after this, I will give you maybe 10 to 20 minutes, no? Para solving yung mga iba pa. Okay? So now, we go now to the number 2 and the problem states that 25, 25 ba yan? Is that 25? By 15 by 25. Direct acting duplex pump. So, pump to, no? So, ilagay natin. So, there is a pump and it's a direct acting duplex. So, pag duplex, dalawahan. No? Direct acting duplex. So, ang kanyang, may notation to ha. Natandaan nyo kung ano to. Notation. May tatlo yan. 1, 2, 3. So, 25 by 15. Normally, ano yun? Yung bore. No? Bore and stroke. Yan. Bore and stroke. Tapos, ito yata ay discharge. Ano tingnan natin mamaya.
So with the piston rod makes 35 double stroke per cylinder. So 35 double stroke. Bisa. Stroke per cylinder. So bawat cylinder. Per minute. So kada cylinder, kada minuto. So bawat isang cylinder, 35. O dalawang cylinder yan. And delivers 510 liters per minute. Ano yun? Yung discharge. So yung volume flow rate o volume discharge, no? Q, that is volume flow rate, no? Sa mga mahalagang parameter sa pump, binigay naman that is 35, ay, ano yan? 510 pala. 510 liters per minute. 510, malaki din. 510 liters per minute of 38 degrees centigrade water. So, binigay din yung tubig, 38 degrees centigrade water against a total head of 140 meters. So, yung total head, no? Total head is 140 meters. And then, the steam, yung pala to, is supplied to the steam end at a pressure of binigay, no? Ano ba yan? 1,034 kilopascal gauge, no? KP. So, ibig sabihin, yan ang nababasa sa metro, sa gauge. And it's exposed to the atmosphere Amount of steam supplied is 1,725 kilogram per hour. Yung mass flow naman ng steam yun, 1,725 kilogram per hour at 0.98% quality. So, ito yung fraction na dryness. So, ibig sabihin, ang pagkabasa niya ay 0.2 na lang. No? 0.98. So, decimal to. So, ito, 0.2 na lang. Pag sa percent, 98%, no? Ito ay 2%. No? So, 100, ang sabi dyan, ito. So, ito ay may quality daw, ng 98% quality, barometric reading of 762 millimeters of mercury. So, iba-ibang unit, no? So, ito naman ay 752 millimeters of mercury. No? So, now, the question is, assume that the piston makes full stroke. No? So, full, hindi siya kulang, hindi siya half. We have 4 questions. Say A, the piston displacement of the pump in cubic centimeter per hour. So, ibig sabihin piston displacement. Ibig sabihin volume, no? So, volume displacement is cubic meter per hour. Sa dalawang, sa two na yan, no? So, meter cube per hour. And then, pump ASHP. Ano yun? What is that? Pump SHP, no? Then, water power delivered in kilowatts. So, yung pangatlo, T is power, water power in kilowatts. Tapos, pump theoretical, thermal efficiency, no? So, pang-apat, is thermal efficiency. No? So, thermal efficiency. So, how do we solve that? So, we continue by solving, it's better for us to illustrate. We illustrate the given, but the requirements, are always in our mind. So, what are the requirements? The piston displacement of the pad in centimeters cubed per hour. So, we have to really follow the unit. Then pump, ano ba, SHP, then water power required in kilowatt, then pump thermal efficiency. So here is the configuration of the piston. It is said tandem. I guess it is direct acting duplex. No? So it is direct acting duplex, meaning they are together. No, no, they are. Ito yung pump isa, ito yung pump na mas malaki, parang ganyan. No? Tapos mag-reciprocate siya. No? So now we have to compute the following. No? So displacement, piston displacement, then the pump SHP, and then the power delivered, water power delivered by the pump in kilowatts, and then the pump efficiency, no, thermal efficiency, if it's efficiency or not. So ngayon, we have this, no, solving for the split, ano ba yun? Yung kanina, split ba yun? Split pala ito, no? Kala ko is, sorry, split, no? Pump slip, meron namang formula dyan, no? So, the pump slip, may formula, what is the pump slip? Number B, no? Pero dito man tayo sa piston displacement. How do we solve, class?
How do we solve the piston displacement in centimeter cube per hour? So the pump displacement, when we talk about displacement, it is just the volume, no? So volume displacement equals this, no? Volume displacement, no? Times the in the piston, no? Happening in the piston, in the direct dual piston. So we will have uh, 2 there, pi over d square times L times N, and pi over 4d square minus small d square times L times N. No? So, yun yung formula natin. Meaning, the meaning of this is we are going to consider the configuration. No? So, this one and this one. The other is uh, the notation for this, no? So meaning dalawa kasi, no? May pumapasok sa kabila, may pumapasok sa kabila, no? Sa kabila ng piston. So dalawang sides, so kaya that's why d square minus d square, no? Both on the side. So eto naman, GD is pi over 4 L and d square plus d square minus d square. So when we substitute values, B equals 25 minutes, 25 minutes, 25 minutes. So this one is, sabihin mo lang 25 meters. Then N is 35, no? Times the cycle, no? Per minute. Then times the, ano ba to? Yung per hour, no? So tingnan natin dito sa problem. Ang sabi kasi ay the piston is full stroke. So, supplied is 175. Ito yung supply niya. So, all naman ay given. So, we just have to plug in the data. No? So, if I may continue, yung length natin, length is what? The length, no? Yung bore length is what? 25. Ayan, no? 25. No? So, 25 meter. Is that meter or centimeter? Centimeter, sorry. So, this one, no, is a 25 centimeter. So then that's the unit. Then the other is efficiency is 0.25. Then other is 0.25. Then N is 35 times 2. Bakit naman 35? It is given in the problem. So na binigay doon na 35, no? Double strokes per cylinder. Yan. 35 strokes per cylinder, no? Per minute. Bawat minuto. So i-consider natin 'yon. We have to do some mathematics. simple mathematics. So this one, we were given this solution, which is ito yung piston, no, yung diameter times stroke. And then this is according to formula. Ito na, no? So, solving this, we continue 4,600, 4,200 cycles per hour, no? Kasi multiply natin to, no? Yung frequency, 35 times 2, kasi 35, double yan eh, 35 times 2, yeah? Tapos per minute, no? And 1 minute, 60 seconds, no? So, 60 seconds. So, 4,000 cycles per hour. So, 15 centimeter yung yung diameter. Tapos, yung mas maliit na diameter ay 4, no? So, the one is 25, the other one is this much, no? 4 centimeter. So, we can get the volume displacement, pi over 4. Then, this small, no? 0.25 times 4,200. Then, dito sa kabilang diameter to, no? 0.15 plus 0.15 minus 0.04. Ito yun, no? 0.15, dito yun. Square minus 0.04 square. Doon yung sa malaki at sa maliit na diameter. So, ito naman ay yung pi over 4.25 yung nauna kaninang diameter na 0.25. Yan. So, if you go to continue this calculation, you will arrive in volume displacement which is 35.79 meter cube per hour. So, ito yung volume displacement. Now, ano naman yung pump efficiency, no? Solving mo natin yon bago natin makuha yung slip, no? So, ano ba yung formula ng slip? Slip is this, no? So, volumetric efficiency, no? Ito yon. Di-divide natin dito sa another value, no? Yung sa displacement. So ngayon, solving for pump slip, volumetric efficiency. So we have this 510 liter per minute. I-convert natin, no? I-multiply natin ng may specific weight tayo, 1,000 kilogram per meter cube. We will have 0.61 cubic meter per minute. No? So we continue 3.079 meter cube per hour. So ito yun. No? Pag nilagay mo sa minute, no, ang gagawin mo lang is 1 hour 3,600 per a minute, no? Para makuha natin dito. Now, the volumetric efficiency, ito yun, no? 0.2510, saka yung nakuha natin 0.595, no? This is the volumetric efficiency. I-multiply natin sa 100, no? So, dito na tayo sa pump slip, 100, no? So, 100, total yan, minus 85.85, ito na yung answer. Meron pa ba? Are there other things to solve? I think meron pa, no? So, we have how many unknown? Water power delivered and pump thermal efficiency. So, how do we do the water power? So, water power has this, no? So, discharge times the density or specific weight times the head. So, we have to get first the specific weight, no? Might water at 3 specific, no? Specific weight of water. So, iba yon. Ito naman, kung hindi, if it's not given, it should be cited, no? Where you get it. Where did you get it, no? So, 992.5 kilogram per minute. So, multiply mo yan. 9.7375. Then, Q, no? Kasi kailangan natin itong sa power is ito, no? Then yung Q
is 0.5010 meter cube per minute. I-convert, no? Natin, 0.0085 meter cube per minute. Tapos yung head is, eto, no? Naka-meter na. So, pag kinumpute natin yan, na mako-compute natin yung head, no? Based dito sa problem natin, no? So, meron na tayong head. Now, water power is this, no? 9.735, ito yun, kilonewton. Tapos, multiply by this 0.085 meter cube per second, we will have this water power na ganito. Yan. And then, sa last, solving for pump thermal efficiency. What is pump thermal efficiency? No? So, efficiency, thermal. No, efficiency, then substitute thermal. So, the thermal efficiency is just nothing but this heat required of water mixer, water power, heat equivalent of water power divided by heat, ano to? Heat, from the end. No? So, meron tayong thermal efficiency, heat equivalent of water power, then heat generated at steam. No? So, ano yun? Paano yun? So, eto, no? Gagamit pa tayo ng ganitong formula, no? Water power, di ba? Yung water power, tapos yun yung power ng steam, which is M delta H, no? So, kailangan nating gawin yan para yung makuha natin ay thermal efficiency, no? Kasi kailangan nating hook heat by means of a boiler, no? Ito naman yung power, yung sa numerator, no? So, gagawin natin yan. Ito yun. So, water power, 11.59 kilopascal, 11.54 no, kilojoule per second. So, he has to find the unit in this parameter, no? So, so kilogram per second, ito yung mga units na per hour, no? So, ito, 164 kilopascal plus 752 millimeter mercury. Tapos, meron kang P1, H1, nasa sunod dyan. Tapos, yung H2, no? At the discharge. Tapos, F1, H1, pala H1 minus HF2 yun. Diba? Times MS, mass of steam. So, kinuha din niya yung pressure, kinuha din niya yung tapos yung H2 is at enthalpy of fluid at 100.28 megapascal equals 417.7582 kilojoule per kilogram. So the thermal efficiency, when you try to get that, it's a bit long. So 11.59 divided by the summation of this, no? Kasi hindi niya dalaga. No? Hindi niya makuha to. So 417.7582. So magiging thermal efficiency is 1.04%. No? Sa class, ang thermal efficiency natin ay ito, thermal efficiency ay 1.04. So it's coming from the water power equivalent, which is 11.69. Tapos ito yung mass ng steam, tapos kasi H1 minus HF2, no? Enthalpy ng fluid. So, meron tayong thermal efficiency na ganyan. So, you continue number 3, ano to? Number 3, 4, 5 ba? Yun, no? So, i-assign na lang sa, mag-usap-usap na lang kayo, class. So, 3, 4, 5, pakisagot, tsaka eto, ilan ba tong problem dito? Para matapos na rin tayo sa pump, no? So, ano ba to? 20? So, number 20, may sagot naman, no? Papaliwanag na lang. 21 ba to? 21. Tapos 22.
23, ilan yun? 24, ano ba ito? 16 ba yan? Iba-iba kasing number eh. 17, 16, 17, 31, no? So may 16, may 17, may 31, no? So tingnan na lang. So ganito, yung natirang 3 class, yung natirang sa notes ko may 3, 4, tsaka 5, no? Ipapaliwanag lang. Tapos etong mga galing sa reviewer, puro naman sa pump yan, no? Ano lang. So I'll give you like ilan? Mga ano? Mga 3 minutes, no? 3 to 4 minutes para paghandaan, and then paki-arrange na lang, no? Hindi na ako tatawag. Isagutan yung o ipaliwanag yung natitirang 3, 4, 5, no? Nandun naman na lahat yon, and then yung mga natitira sa reviewer. Okay? Ayan, nakikita ba?
Kita naman po.
O sige. Ikaw na sige. Sabihin mo lang kung ililipat or paano. Sige.
So,
Basahin mo muna yung problem.
a submersible multi-stage centrifugal deep well pump, 260 GPM capacity is installed in a well 27 feet below the static water level. Drawdown when pumping at rated capacity is 10 feet. The pump delivers that water into a 25,000 gallons capacity overhead storage tank. Total discharge head developed by pump, including friction, is in piping is 243 feet. Calculate the brake power required to drive the pump if pump efficiency is 70%.
Oh,
So yun po. So with the
muna
formula po na PB.
sabihin mo muna yung mga can you enumerate yung given muna?
So yung given po, yung pong flow 260 gallon per minute.
Yan ba yun? 20 ba yun?
Yan po yun.
Sige.
Yung Q natin, volume flow rate.
Sige.
Then,
260 ba yan?
medyo malabo lang.
Oo nga, malabo nga. Sakit sa mata.
Tapos head po, 200 to 27 feet po. Head
Yung head.
1.
1 lang ba to?
Tatlo po kasi yan.
Ano? So 1 to, 1. Below
Tapos
the static water level.
yung head to and then
below the below the static water level. Okay, sige.
may isa pa pong head 10 feet.
Ano yung 10 feet na yan?
H2 po. Yun po kasi ako magsagot sa
Okay lang. Drawdown when pumping at rated capacity is 10 feet. Okay. Drawdown.
Tapos po, may isa pa pong 243 po.
Ano yun? Total discharge head developed by
Friction
pumping.
head po.
Friction head. Okay. So, yun ang total, no? Ito, head, total, kasama yung friction na yan, no? Lahat na ay
243.
feet ba yan? Yan.
Then, pump efficiency po 70%.
Sandali, yung 25, ano yun? 25,000 gallons capacity over, storage tank.
Storage tank po.
Yung tangke,
Ayun.
yung tangke niya, yung tangke na to, ang sa overhead, no? Developed by pump, including friction head, capacity, overhead storage tank, no? Ito yung overhead, mataas, no? Overhead, eh. Siyempre, may ano yan, merong mga may paa, no? Kasi overhead. So, ito meron capacity na magkano?
25,000
gallons. Yan. Yun ang capacity niya. Tapos, yung total nga, ito 243 feet. Ano pang, natin?
Pump efficiency nila po.
Yung determinant brake power, ibig sabihin yung, ano yan ha, pag sinabing brake power, yung sa labas ng motor, shaft. Tandaan mo yan. Pag sinabing brake power, shaft yan ng motor, input yan sa pump. Yung papasok sa pump na torque, di ba?
Sir.
Papaikutin niya yung pump galing sa motor. Required if the pump efficiency is, pump efficiency is 70%. Yan, kumpleto na. Yan. So, anong start natin?
So, yung para makuha yung brake power, may formula po tayo. Ano yun? Power po ng pump. Power po.
Calculate the brake power. Hindi, binigay muna yung yung solution
Yung
sa
formula po. So, 3 brake po equals
power brake. Ibig sabihin yung power brake is what?
power ng brake.
Ano yan? Kasi
Power po ng pump.
sa taas.
Wait lang po, hindi ko mababasa.
Hindi mabasa no? Kasi yung pagka-scan, total, ano ba yan? Power water? Water power ba yan?
Power of water po.
Yun. Yung total na power ng water, di ba nakukumpara?
Over efficiency po.
Over yung binigay na efficiency.
Up.
Diba? Eta, efficiency. Yan. Kasi tayo magsimula.
So, sa Q po. So, yung Q po, since nakagalan po siya, pwede po natin siyang convert. So, 260 gallons per minute over 1 cubic feet over 7.40 gallons. So, makukuha po natin ay 34.76 cubic feet per minute. Then, for the total
7.48
gallons
gallon, ilan yun? 1.
per 1 cubic feet.
So, cancel niya. Na?
Cancel na po.
Yung gallon, magiging cubic feet na lahat yan. Ilan yun? 30?
4.766 po
Cubic feet
per minute.
Yan.
So, may Q na po tayo. Bale, sunod kong ginawa, kinuha po yung total dynamic head.
Ito.
Apa.
Paano yan?
So, bale po yung total minus yung 27 minus 10.
Di ba binigay yung total na 243? Kasama
Apa.
yung section?
Given po lahat yung
So,
head na yun.
minus natin. Saan galing yung 27?
Sa
Yung sa binigay na yung kanina.
apa.
Below
Static water level.
Below static. Isa naman yung sa pump.
Pump. Draw down.
So, ito yung sa drawdown. So, imaminus natin yan. Yan. So, ilan na lang to?
So, 226 po.
250. Yan. Okay na to. Yan.
Tapos, para po makuha yung power po ng water, gagamitin po natin density times Q times total dynamic head.
Ito yung
Yung gamma gamma Q times EDH po. Yan. So, direct substitution na lang po, ang ating pong gagamitin ay 62.4 pounds per cubic.
Kasi English, di ba?
English po yan.
Ang tubig sa English ay 62.4 pounds per
Cubic.
foot. Tapos yung discharge na natin.
Yung nakuha po natin kanina na 34.766.
Yung sinunod natin nakuha natin. 34.766
Cubic.
na CFM natin.
And tapos po yung 226 ang ating total dynamic head.
Lagay natin dito. 2,
So, may makuha po tayo
magiging 6 pounds per minute. Tama?
pound per minute po matitira. So, bali may makuha tayo 490,000.
Hindi, i-convert pa natin, di ba? Ayan,
Apa. Yun po yung makuha po natin, i-convert po natin gamit yung
conversion factor. 33,000
33,000
per
equals to 1 HGP po.
bawat horsepower. Meron kang 33,000 foot-pounds per minute.
So, bali, makuha po natin ay 4.85 horsepower.
Tapos,
Yung po yung power ng brake. So, isa-substitute lang po natin yun. P brake equals power ng water over efficiency.
So, ito na yung brake. Diba?
P brake. Since nakuha na po natin power ng water.
Pag dinivide mo siya sa
Efficiency. Nasa 7%. So, 0.7.
over efficiency. No? Pump ba yan?
Pump.
So, P-water ngayon ay magiging
4.85 over 0.7.
ito rin. So, magiging 4.85 divided by the efficiency of 0.7 magiging
21.22 horsepower. Yun po yung brake power natin.
Yung ba yung tinatanong? Yung brake horsepower?
Up, brake power po.
Tapos na ba yan?
Tapos na po, sir.
Okay. O, sige, isa na lang. Tapos uwi na tayo. Sino pang mag-volunteer?
Ako na lang po, sir.
Sino yun?
And pali po. Is a centrifugal pump operating at 1,800 RPM develops a total head of 200 feet at a capacity of 2,500 gallon per minute. What is the specific speed po? Bali po, ito po ay layer of substitution lang. Empirical formula po siya. So, hindi na po need, basta po masusunod po yung need pong units. So ito po, for the N po, we have 1,800 revolution per minute. So ang Q po natin is the volume flow rate, 2,500 gallon per minute. Tapos po ang ating head ay 200 feet. So direct substitution lang po. Bale, ang sagot po ay 1,690 revolution per minute po.
Basta yung formula lang ng specific speed.
Opo, sir.
Pero
dapat po ay sunod po yung units po.
Units. Ano yung unit ng N?
Revolution per minute po. Tapos,
yung
ang head po ay feet. Tapos, gallon per minute po ang volume flow rate.
So, English yan, no? Imperial or English yan, no? So, pag kinalculate nyo yan, ang sagot ay 1,690.
po.
So, anong letter yon? Letter B.
Opo.
Letter B.
Opo.
Okay?
Sir.
Dapat yung mahaba-haba naman. Sino yung medyo mahaba? Diretso lang to eh. Sino mag-volunteer? Isa na lang, last na lang. Sorry. Yung medyo mahaba.
Yun to, sir.
Yung 2?
Sir. Wait lang po.
Di ba na-take up na natin yan 2?
Nakuha na ba, sir?
Oo. Tapos na yan.
Wait
Diba
lang,
yan? Yung 3. Pwede naman yung 3, 4, 5. Pare-pareho lang naman.
sir.
Sige. Okay lang. Kasi tutulungan naman. Okay lang ba yan? Magulo yung sulat. Malabo yung sulat. Malabo yung sulat ko dyan. Baka hindi natin mabasa eh. Yung tinan mo nga yung 3. Okay lang yung 3. Pagtulungan na lang natin, ha? Kasi,
Hindi ko gano'n intindi ang 3.
sige. Okay lang, basahin mo lang. Tulungan
Okay,
lang.
sus.
Sige. I-present mo ng full. Yan. Okay, basahin mo muna.
Number 3.
Okay.
A motor-driven centrifugal pump rated at 70 at 10 kilowatt and having an efficiency of 70% serves two elevated tanks through a common discharge pipe. The first tank has a capacity of 80 meter cube. The second tank was located at a higher elevation than the first and has a capacity of 50 meter cube. The inlet of the lower tank is provided with an automatic shut-off valve so that when the tank is full, the valve automatically closes. The tank will be filled one at a time with the pump power remaining constant. When filling the lower tank, the head of the pump is 12 meter and when filling the upper tank, the head is 21 meters. Find the total time required to fill the two tanks starting from empty with the lower tank filled first. So merong first tank located at high elevation. Ito simulan natin dito. So yung motor niya 70
Lahat ng
watt.
given, ha? Lahat ng given.
Yung motor yung centrifugal pump niya, ang power niya ay 10 kilowatt, tapos may efficiency 70%. Tapos, ang sunod ay, yung first tank ay mayroong capacity na 80 meter cube. Tapos, ang second tank naman may capacity na 50 meter cube. Tapos, yung sa elevation naman ay, nasa next. Tapos, ang nakalagay dito sa solution is solve yung water power input times efficiency. Yung input nga kanina, yung sa power dun sa sinabi ko, 10 kilowatt times yung given na 7 efficiency, 7 kilowatt lang. Pag sinama natin yung water power ay 7 kilowatt lang kapag at 7, yung 70% efficiency. Tapos, solving for discharge when filling the lower tank, ang formula na ginamit ay water power equals yung discharge times yung specific weight ng water times yung head. Ngayon, yung water power natin kasama na yung efficiency 7 kilowatt. Solve na po. Tapos yung discharge alamin natin para may malaman kung gaano katagal bago puno. Tapos ito, yung specific weight ng water, at na naman yan, 9.81 kilonewton meter cube. Tapos yung head na 12 liters. Tapos pag kinalculate yan, ang sagot na magiging discharge natin ay yung 0.05948 meter cube per second. Yan yung discharge.
Doon saan yan? Saan banda yan?
Wait up. Sir, ano pa yung dito sa part na ito?
Dyan sa lumabas.
Opo.
Paglabas dyan, paglabas sa sa pump. Sige. Okay.
Wait. When filling the lower tank, tama dito. Kasi ito po yung lower tank. Tapos, yun yung discharge natin sa lower tank. Tapos, T1, let T1, yun yung time to fill the lower tank, yung pinakita kong unang tank kanina. Ang formula ng T1 ay volume 1 over Q1. Ang volume 1 natin, ito, 80 meter cube yung pupunin natin. Tapos yung nakasolve natin yung discharge. So, substitute na lang dito sa formula. Ang makukuha natin, ito, 1,344.999 seconds para mapuno yung unang tank. Ito, para mapuno ang itong lower tank. Tapos yung sa...
Ano yung volume ng Ano yung volume ng 1?
Yung volume ng 1 po ay 80 meter cube.
80 meter cube, no? I-divide nyo sa volume flow rate. Di ba natin yung volume flow rate, yung may 70%? So, matitira ang seconds, di ba? Pag dinivide mo.
Seconds. Tapos yung seconds na yan, pwede naman natin convert sa 1 minute over 60. Ang magiging sagot pag minutes, 22.42 minutes. Tapos, solving for the pump discharge when filling the upper tank, ang upper tank natin ito.
Meron din siyang volume, no? Anong volume niya?
Ang volume ng upper tank na pupunuin ay 50 meter cube.
Okay. So, meron ba tayong volume flow rate dyan? Makukuha ba natin yung cube?
Gagamit po ulit yung water power. Since isa naman yung centrifugal pump na may efficiency kanina yung 7 kilowatt. So, given dito water power equals yung sasolve natin itong Q2. Tapos, yung specific weight ng water. Tapos, yung sa head na 2 meters. Tapos, pagka sinubstitute ito, ang makukuha natin flow rate, pag naman ipili ito sa substitute, ang makukuha natin flow rate ay 0.3999 meter cube per second. Tapos, ganoon din sa kanina.
50 divided by volume flow rate, no?
Yun po ulit. Kasi time dito kailangan.
Para lumabas yung time.
Let T2 time to fill the upper tank, yung pinakataas yung pangalawa. Tapos yung sabi ko kanina ng volume, 50 meter cube over yung nakuha natin yung Q2 na discharge, which is ito value 0.3399. Tapos makuha natin 1,471.0209 seconds. Tapos convert natin Sa minutes, 24.52. So, ang total time para mapuno yung dalawa is pag-a-add natin yung T1 at T2, yung 22.42 tsaka 24.52. Ang total time, 46.94 minutes para mapuno yung dalawang tank.
Kasi one at a time lang naman, di ba? Pag napuno yung isang tangke, yung isa naman. Di ba?
Opo, sir.
So, tapos na ba yon? Wala na yon?
Opo, sir.
Okay.
Okay na po.
Thank you.